Acme is wondering, what is the estimated life under normal use for these Yamaha seals to last? I'm at 575 trouble-free hours on a Yamaha F70, best motor I've ever had, and we are talking about prop shaft seals, drive shaft seals, basically all the seals that are on your lower unit. Welcome to the Boaters Podcast, a podcast all about boating and outboards and anything that's on the boat. This show is brought to you by you. Everybody that is part of our Boaters program has purchased a shirt or joined our school community where you can get into contact with me and ask me questions, DMs, messages, stuff like that. More of like a one-on-one type of deal. That is where that happens. We thank you for supporting this and bringing you this content and keeping it going. Now, as far as your seals go on the lower unit, especially on a Yamaha, there isn't really an hour or let's say a time frame on them. So the main thing on a Yamaha with the seals is that each seal is a rubber seal and there is a metal spring that goes around it. The spring basically constricts the rubber against the shaft, whether that's the drive shaft, the prop shaft, the shift shaft, doesn't matter. It's basically the same design on virtually all of their lower units. Some of the small ones, the shift shaft just has an O-ring around it, but the rest of them just have that same. It's a lipped seal with a spring around it that keeps it in there. There's two seals there, and it's pretty bulletproof. The spring eventually, because it's on the outside, will rust, and when that spring rusts, it will break off, and then now your seal is damaged. Or if you get, say, some fishing line around your propeller and it works its way up around that seal, as it spins, it will melt or burn, or it destroys, scratches the rubber seal, which will make it leak. So there are two seals because there's not as much pressure as you would think inside of the gear case. Usually when we pressure test a gear case, we do not put more than 10, 12 PSI of pressure into it. With the gear case running, with the gear lube in there and everything, it doesn't really pressurize much more than that. I do not know the exact number of how much pressure a gear case makes when it is operating at, let's say, 4,500 RPM, or let's say you've got a 2-to-1 gear ratio and it's running at, say, 3,200 RPM. So I don't know the exact pressure in there. And I say 3,200 because if your engine is running at 6,400 RPM, because of the gear ratio in the lower unit, the propeller is only going to be spinning half of that at a 2-to-1 gear ratio, which a lot of them, smaller gear cases, have a 2-to-1. Most of the larger stuff, 300s, 350s, 150s, 200s, 250s, those are all around a 1.65, 1.75, 1.85, something in the 1-to-1 ratio there. Now, the seals themselves, as far as putting an hour on them, you can see prop shaft seals that will last, or drive shaft seals for that matter, last well over. You got 575 hours on them and no issues. So depending on also the environment that you run in, if you run in salt water, then those seals are going to corrode, they're going to rust, and the springs are going to come off a lot quicker, which is going to make the seals fail. Whereas if you're in fresh water, that spring might last a whole lot longer. There's people out there that have run Johnson gear cases for 20, 30 years and never changed the gear lube or the seals or any of that stuff. They might change the gear lube, but yeah, it's amazing the difference there. And a lot of that goes back to that spring being metal, rusting, breaking, falling off, and losing the efficiency of the seal and how it works. That's pretty much it for prop shaft seals, drive shaft seals. It's not really an hour mark. It is more a environment mark. And as long as it's maintained, like if you're doing impellers every 300 hours, I like to grease up the seals. So every 100 hours, if you're taking the prop off of your lower unit, as you should be, you grease up the prop shaft. I like to smash grease all around that spring, all around that seal. So that way the grease helps to repel water and kind of puts a protectant on it. Once you're running the lower unit, the exhaust blows a lot of that grease off of there, but there is some residual that stays on there that helps to protect that spring to make it last a little bit longer. So every 100 hours, if you're doing that, and then when you do your impellers, do the same for your drive shaft seals, it should pretty much last a long time. You got 575 hours, so there's no reason it shouldn't last longer. It's not like it's a maintenance item, I guess you would call it. It's a seal. When it fails, it fails. Maintenance items are going to be more like spark plugs, gear lube, oil filters, stuff that gets dirty and wears out with use. Though a seal wears out with use, it's not considered a maintenance item. Moving on to Door Flanagan. How do you go about measuring your pinion height? Doing a lot of gear case videos, so obviously we're going to have some gear case questions going on today. But the pinion height totally depends on the gear case. It is the first step in shimming a gear case or doing any kind of repair on a gear case, a lower unit. If you have to change out bearings, races, the cases, stuff like that, a lot of times you can get away with changing out your gears, your bearings, and that kind of stuff without having to reshim the case. But when you do have to reshim the case, the pinion height is the first step, because that pinion height, if it is not correct, it's either going to be closer or farther away from your gear, which is closer to creates friction, which would cause premature failure. Farther away would cause clipping, which would also cause premature failure. And to check the pinion height, you got to have special tools. I have not really found a way to get away from using special tools. And the reason that is because the tool, you can get an aftermarket special tool, but the dimensions of it have to be exact. And that is because what the tool does is it goes into the gear case and it leaves holes where you can put a feeler gauge in. And on the end of it, there is a knob, and that knob is virtually your clutch dog. Let's not say it's virtually your clutch dog, because it's not. I mean, it's a lot bigger than the clutch dog. The clutch dog is not near the distance between the drive shaft pinion gear nut and the bottom of the drive shaft. The clutch dog is going to have a distance there, but it does have a specific, like when you put it into the gear case, based on your gear case, it is in a specific spot. And then based on that spot, when you put your feeler gauges in there to feel or check the dimensions between the pinion gear and that tool, that's where you get your pinion gear height. So there isn't really a way to measure that pinion height without that special tool. And it's not just one tool either, because there are tons of gear cases. Back to having different gear ratios, smaller engines versus larger engines. Brands based on, Mercury, Yamaha, Suzuki, Honda, they're all different. I mean, one gear case isn't like fits all, especially, 25 horse versus a 300 horse. They're totally different gear cases with different gear ratios, different size gear, different gearing, being that 175, 185, 165, 145, 20, tons of different gear ratios and gear reductions based on the brands, the lower units, and the sizes. So if you're rebuilding gear cases, you got to have a lot of different tools in order to do that, because each one is going to be different. So kind of one of those issues there, but that's how you do it. Depending on which gear case you're trying to rebuild, you got to have the tools, which is another reason why it's kind of like a dying art, because there's so many different gear cases out there. Somebody's going to have thousands and thousands and tens of thousands of dollars worth of tools on hand to be able to rebuild different gear cases. So it's a dying art because of that, because normally when you become a dealer, the dealer has all those tools, but outside of the dealer, again, they've got to purchase those tools too. So it's massive cost difference there. Superman says, do Mercury Optimax lower units come off that easy? I have an 04 Optimax 250. Generally, yes. Mercury lower units, the lower unit coming off totally depends on when the last time it came off, and also what's the condition that it's been run in. Somebody that runs in South Florida saltwater and doesn't take their lower unit off for 4 years, you got a problem. That is a legitimate concern now on whether or not that gear case is going to come off. And also the oil, especially on 4 strokes. And Mercury Optimax is a 2-stroke. Most 2-strokes, I'm going to say most, not all, but most 2-strokes, you're burning oil, you're sending oil into the crankcase, and a lot of them have a lot of oil running around in there. So usually the 2-stroke lower units do not get stuck on. If they do, it's down around the bottom, around the locating pins, or the bolts, stuff like that. But usually you can tap them off with a dead blow, block of wood, chisel them off. They usually come off pretty easy. 4 strokes are different. So a 4-stroke, you run into the problem of heating them up. So a Mercury Optimax, most of them lower units come off. There are certain ones, like I want to say it's the 150, where putting it back on can become difficult depending on which one you have, because on an Optimax, on certain ones, up in there underneath the crankshaft where the drive shaft comes up through, there is a spacer up there, or a washer, whatever they call it, thrust washer, washer, spacer, whatever. There's a ring that's a washer basically, and that washer, your engine, you tilt it up like this, you pull the lower unit out. When you pull that lower unit out, this engine is tilted like that. That washer is sitting like this. Now all of a sudden that washer, boom, it falls down. And when it falls down, you put the drive shaft back up there, it doesn't line up. And now all of a sudden you're hitting that washer. That model there, I want to say it's the 150. I can't give you the exact if it's the 2.5 liter or which one it is, but I think it's the 150, not the 250, but the 250 might do it too. I can't remember which model exactly does that. But then in that case, yeah, you got to tilt it down and like kind of like shimmy it up there and put something up there to kind of grease it up, to get the spacer up there to stick up out of the way so you can slide the drive shaft up in there. It can be a pain. The rest of them, yeah, they all come off easy, go up pretty easy. I mean, it's a lower unit. It's not like old stuff. Everybody knows the story. 4-stroke though, back to that conversation. The issue that you get with 4-strokes, and depending on the model, is the heat and the oil. So most of the drive shafts in a 4-stroke, they go up through the oil pan, go through an oil pump into the crank, the power head. When it does that, that oil is usually, most of them are splash lubricated where it pumps the oil up and then it all just kind of like falls down inside of the crankcase. It's not really splash lubricated. That's kind of different, but in a way it is. Either way, doesn't matter. It's not what we're talking about. The oil usually goes up and it cools everything down. If you run low on the oil, because that drive shaft goes up through the oil pump, through the oil pan, into the crankshaft, if that goes low and now all of a sudden you're not getting enough cooling and it's getting hot in there because you are running it low on oil, that heat can build up and basically, I'm not going to say weld, but it basically welds the drive shaft into the crank, which is the biggest problem with getting them off. They run dry, and then especially on other models like certain ones, a 3.3 Yamaha, other ones, the drive shaft is exposed when it goes up through that oil pump. So like right there, it is exposed. If the seals fail and you're on the worst are catamarans because of the way a catamaran goes through the water coming off the hull splashes up on the belly pan all over the bottom of the engine, that water can get up in there. If that's salt water, all of a sudden now that drive shaft is going to freeze in the crank and it doesn't come off. People up north have never dealt with that. It's not even like the conversation there is two different experiences. Someone might look at what people do in South Florida to get lower units off, and they're like, well, why would you do that? That's ridiculous. You're just damaging the lower unit. But they've never had the experience of that. They don't know what a engine that has been run low on oil, abused, and hasn't had the lower unit off in say 3, 4, 5, 6 years in salt water, 90-degree calcium, lime, massive minerals in the water that creates this corrosive environment. The lower units don't just come off. And even, you can even try and wedge them. You can do whatever you want to do. But if you've run them low on oil and that welds itself in there ain't nothing you can do to get it off. So that's one caveat, is making sure that the engine has proper oil in it and it's not running low, because that is a byproduct. And then also, if you live in an environment like the Bahamas, the Caribbean, South Florida, don't wait 5, 6, 7 years to take your lower unit off. Take it off, grease it, because if not, you run the risk of destroying the engine. Because if the drive shaft welds into the crank, it's it. Like you're not taking a $4,000 or $5,000 engine apart and rebuilding it with a new crank and all that stuff. It's going to way exceed the value of that engine. Not to mention, you're going to have to buy a lot lower unit, because the way you take them off is you drill a hole this size in the bottom of the drive shaft housing, so that way you can take a Sawzall and cut the drive shaft off so you can pull the power head off in order to get it off. So crazy ordeal. Not really what you were wanting to talk about, but in answering your question, gave a good story. Thomas says, can you use Yamaha products like ring free in Mercury engines? I'm sure Mercury would say no and Yamaha would say no, but I would say yes. It's just a fuel additive is a fuel additive. What it does is it helps clean. So, obviously Mercury is going to want you to use Quicksilver Quick Clean, and Yamaha is going to want you to use Yamaha Ring Free. They basically do the same thing. I think they are both outstanding products. If you have a Mercury engine and the only thing available is Ring Free, ring free is really good for the engine. I mean, I would put that in my fuel and run it through the Mercury. It's not going to harm the engine. It's a cleaner. It cleans, it's a fuel additive that cleans your fuel. It helps combat carbon buildup and other things like that. So I would say yes. I'm sure if you talk to a legal representative of these companies, they'd probably tell you no. But I mean, I highly doubt something like that would void your warranty. It's a cleaning product. They both make the same product. It's probably close to the same product. I mean, I think they're both great. I've seen engines, both Mercury, Yamaha, whatever, taken apart where someone uses ring free or quick clean, and the engine is 100 times cleaner on the inside than ones that don't run a fuel additive like ring free or quick clean. James Townsend says, what does starboard shift not working properly message mean when you have a single 225 setup? So this is an error code that happens on Mercury if you have a problem. The only reason it says starboard, and this is kind of goes on all brands for the most part, is even though you have a single engine application, all of your okay, let's put it this way. So most of your single engines, you have a right-handed gear case. It's a standard rotation gear case, and you have a left-handed or, counter rotation gear case. A standard rotation gear case, that engine is considered a starboard engine. It's going to be your outside starboard engine. If you have twins, you have a starboard and a port. If you have trips, you will have a starboard inner, and a port. If you got quads, you got starboard inner, port outer. So basically, if you have a single engine, the engine is considered a starboard engine because it's a right-handed gear case, and that's a single starts from the right, basically. Again, doesn't really matter the brand. That's just kind of the setup of outboards and multiple outboards and how that is considered as far as the location goes. And that's important because the location of the engine, especially in any engine that's built in the last 20 years from probably 200 and up, most of them are fly-by-wire. I mean, most everything is either digital throttle shift, digital electronic control, fly-by-wire, whatever you call it, doesn't really matter. It's an electronic controlled engine, and the engine location is key because whenever you move your handles at the helm, that needs to know what location that engine's at. You don't want to move your port throttle control and operate your starboard engine. It's just kind of how that goes. So that's why it says that. But as far as your shift not working properly, that's because you got a shift problem. Whether your shift actuator is failing, your lower unit is failing, your shift shaft is getting stuck, or you have an electrical problem feeding the shift actuator. Whatever it is, low power, if you don't have enough 12 volts at the engine, that can cause codes like that. But yeah, that's what that code basically is telling you, that you got a shifting problem, whether that's any one of those issues. But the reason it says starboard is because the location of the engine is the starboard location. Clark Hill says, so would a misfire in a cylinder cause prop shatter? It can, yes. Normally, think about a cylinder misfire. So when you have a cylinder misfire, you got a running issue with the engine. An engine is balanced. So no matter what the engine is, it's either got a harmonic balancer, it's got the firing order is developed to minimize harmonic balance, which harmonic balancing is basically the balancing of the engine. So your pistons are going up and down all the time, whether they're in line or they're a V engine configuration. With that, this piston's throwing this way and this one's throwing this way, and it's got a single spot. So like when this throws this way, it's going, it's putting tension on the crankshaft to go that way. Same thing, vice versa. So with all these pistons moving, all that stuff it's throwing itself out. So you have to balance that, and they call the harmonic balancing of the engine by either a balancer on the flywheel, a balancer based on the firing order of how the pistons are going, which one is on top dead center compression, which one's in the middle, which one's on exhaust. Like when that engine fires to bring your compression, it balances itself out. Or you have balancers on the crankshaft, you have a balancer on the front of the engine, like you have balancing built into the engine. And anything that throws that balance off, like a misfire or a cylinder that's not firing properly, that will throw off the balance of the engine. When that throws off the balance of the engine, vibration. You get a vibration. So generally when we talk about prop chatter is a vibration or that chatter developed by the propeller, not from the engine. An engine misfire will create a vibration which could result in prop chatter, but generally you can tell the difference in a running issue, vibration of the engine versus a prop chatter creating a vibration of the engine, if that makes any sense. Prop chatter is usually done because of preloading on the pinion gear or the thrust washer of, not the thrust washer. It can be the thrust washer. If you put the wrong thrust washer onto a propeller, it can create prop chatter, but generally it's the hub of the propeller. Most of them have dampening systems. There's so many of them, different propellers, different brands, different names, but they all virtually do the same thing. So, you know, whether you got a prop tech, you got a Yamaha prop, you got a Quicksilver prop, you got a Mercury prop, you got a, you know, I'm just trying to think of other ones. I can't even think of all the other different brands out there that make propellers. The hub, a turning point, that's what I was trying to think of, but the hub of the propeller, there's different hubs for different applications. You have the SDS hub, which is a silence dampening hub. You have, the flow torque, the reflex hub. Different ones are going to create different things. A lot of the SDS hubs have the rubber hub in there that will, I'm trying to think of the way to describe what it does, so that way it makes sense. Think about, you know, your prop shaft is metal and your propeller generally is metal, a stainless steel propeller. That propeller has weight to it, metal. The two metal together, it's going to click, it's going to clatter, it's going to vibrate because of how heavy this is and how fast this is spinning. So if you put rubber in between the two or you offset them so something else takes the weight out of it, it basically is a dampener that will absorb the difference between the metals, that will alleviate or remove a lot of that chatter that you can get. Also, if you got a smaller engine, you got an inline 4-cylinder. Inline 4 is probably the most unbalanced engine out there, harmonically speaking, based on being 4 cylinders in line compared to like a V4 or an inline 6. The inline 4 is very unbalanced. That's why they have balancers built onto them. That engine, if you take one of the, especially like a 115 or a 90 or a 150, something like that, depending on the application, you throw an aluminum prop on there. The aluminum prop's pretty light. It doesn't ever have any chatter. You throw a stainless steel prop on there, that stainless steel prop is way heavier than the aluminum. So now all of a sudden you got the weight of that prop, which can create prop chatter in low gear because the weight of the prop and then the slow spinning of the prop shaft. Let's say you've got a 2-to-1 gear ratio in the lower unit, just to make the math easy. I know most 150s do not, or 115s inline 4s, they do not generally have a 2-to-1 gear ratio. But if you did, and you're idling in gear at 600 RPM, which is generally the idle RPM, 600 to 700, somewhere around there, that prop shaft is spinning 300 times per minute. The weight of the stainless steel propeller can throw off how fast this is spinning based on the propeller is spinning, pushing against the gear case, and it's also pushing the weight of the boat forward. The whole way that all works, it's just not enough weight to keep a load on that prop all the time, I guess would be the best way to say that. And so you can get a prop chatter there because of the weight of that stainless steel propeller. But then as soon as you advance that RPM up to, say, 900, the chatter goes away because the weight of the prop is now spinning fast enough for it to keep a load pushing that boat through the water, and it eliminates that prop chatter. That's kind of what we're talking about, prop chatter versus like a cylinder misfire, which is going to be, one cylinder's throwing off the balance of your engine, creating a vibration, whereas the prop chatter is the weight of the propeller and the way the gears and the weight of the boat and all that stuff are reacting together based on the hub that you have, which can create a chatter of the propeller. It's loud, you can hear it, and then also you'll see a vibration in the engine because of that. So two different things creating a vibration in the engine. long-winded way to talk about prop chatter and engine balancing. X Zeeb says, hey mate, do you have to purge the fuel rail if replacing the high pressure fuel filter? Normally not. On a gasoline outboard engine, this is talking about the high pressure filter on an F1, on a 150 engine. Generally no, the filter, you just take it out, put the new one in there. Whenever you turn the key on, it primes up the fuel system. There'll be a little bit of air in the rail, and as soon as you turn it over 4 or 5 revolutions, it's going to inject all that air into the cylinder. It's going to push all the air out the exhaust, and it's going to self-prime that system. It's generally no, you're not going to have any issues there. You can just crank the engine over a couple times. It'll prime itself up, and then boom, it'll start. It might run rough for a couple seconds, but then it'll clear right up. It's generally no, you don't have to. Matthew Cinnamon, that's an awesome name there. I have a question. I've been looking at some used center consoles around 17 feet, and I wanted a Yamaha outboard, but they are pretty expensive. Yes, they are. In your opinion, do you think a Mercury Optimax or Evinrude E-Tech would be more reliable? Absolutely not. I would not say that a cheaper Optimax or cheaper Evinrude E-Tech is going to be more reliable than an expensive Yamaha. Yamahas are branded reliability. I mean, if you ask 100 people that have ever had a Yamaha what they would say, the one word to describe it is, they would say reliable. I mean, Yamaha is known for reliability. Not to say that the Optimax or the Evinrude isn't reliable, but is it as reliable? Most likely not. And especially when you throw in the expensive Yamaha, probably because it's in better shape than the cheaper Optimax E-Tech that's probably not as in good of shape. So would I say that they are unreliable? No, I wouldn't say that. As far as the Optimax goes, as long as that thing has been taken care of, it is super reliable. It's very fuel efficient, and it packs a punch because it's direct injection 2-stroke. So it's a phenomenal engine, though a couple caveats there. They do not like to sit, and you better keep good clean fuel to it, because if you get dirty fuel or you put ethanol in there and you let that ethanol sit, you are asking for trouble. You're asking for problems. No bueno there. But other than that, as long as it's taken care of, maintained well, and you got good clean fuel to it, reliable, awesome, fuel efficient. The E-Tech, I've always said this about an Evinrude, is it's a 50-50 brand in my opinion, because it's been my experience that I will talk to 100 people that have owned an Evinrude E-Tech, and 50% of them will say it's the best engine that they've ever had. They've had no problems. They do nothing to it, and it is just an outstanding engine. The other 50 are going to say it's the worst engine they've ever had. They've had nothing but problems, and they can't stand them. So that has gone on for a very long time. From the FIC to the E-Techs to the G2s, that's the experience. Some people will do nothing to that E-Tech, and it will just start and run every time, no matter what. They don't do anything to it, and it just runs all day long. Somebody else, they try and do the same thing. The EMM clogs up, burns up the computer. They get poor fuel. The injector's all messed up. It's a big deal to change out the injectors because you got to have the computer to serialize them. The motor mounts are breaking. Just all kinds of stuff. It's corroding, and the things are failing. The flywheels are failing. The magnets are coming off. The stators are melting. It's constantly got electrical problems, like all kinds of issues people have with them. And the other half, like I said, they do nothing to them, and it is the most reliable engine they've ever had. So that's been my experience dealing with all kinds of different people. Carl says, how deep of a gouge do you think this process would work on? And he is talking about a gouge in a cowling or repairing it, or you can put this on anything. A gouge in fiberglass. So big key word there is gouge. So a gouge you can fill in, boom, easy peasy, not gonna have a problem. If you have a crack, that is different. So if you have a crack in fiberglass, you cannot just fill it. Everything on a boat is vibrating and flexing all the time. As the boat goes through the water, everything is flexing. The boat is flexing. The engine is shaking and vibrating. The cowling is vibrating and shaking. When it hits the water, it's, going from one speed to another speed. It's taking a lot of abuse, and it is flexing. So as the fiberglass flexes, if you have a crack, that crack is going to enlarge. And so if you have a crack, it has to be fixed with glass. But if you have a gouge, like a scratch in the Gelcoat or a gouge in the Gelcoat or the paint or something like that, you can fill that and then paint it or gel coat over it, and it will be, or you could fill it with gel coat really, and you won't have any problem. So gouge you can fill, scratch you can fill, but crack cannot fill that. The crack will enlarge. When the crack enlarges, the repair that you filled it with will pop out and it will fail. So keyword gouge. Gouge, I mean, you can fill a pretty deep gouge. Once it gets to a certain point, we're talking about a crack. That's different. Richie Ellis says, Ridline works really well. Be prepared to have your heart ripped out when you discover big holes in your engine. My old 2002 Yamaha 250 two-stroke didn't have a great pea stream, and we flushed it for 6 hours with Ridline. Well, all the crap came out and it peed just fine after that, but it exposed a gigantic hole in the block that was previously being redirected by the clog, so the top of the block jacket could still get water, RIP. So yeah, Ridline is a phenomenal product. If you have a cooling system that's clogged or has a lot of buildup in it, Ridline is going to clean it out amazingly. The problem is on older stuff, especially, you're talking about 22 years old, the older it is and the worse it was abused, if it was never flushed and it's always ran in salt water, always ran in a harsh environment, then the damage that's being done by the corrosion, you can get the blockage out of there. You can clean the corrosion out. But the problem is that underneath of that, in certain spots, if the damage has gone on for too long, yeah, the metal's gone. Like the engine block itself is gone. So that's kind of the issue of if you have a problem with an engine overheating because it's got so much buildup in it, you are kind of on a 50-50 stretch there, because you can get the blockage out. We can clean it. No problem. Easy peasy all day. Put it on the Ridline, clean the engine, cooling passages will be spotless. But if that stuff has been sitting in there for 20 years, or let's say 15 years, eating away at the metal, whenever you remove that, the metal might be gone. So at that point in time, even if you were to figure it out, what I like to do is take the spark plugs out, put it on the flush attachment, try and block off, everything but the tail, and in the exhaust. You can't really block off the exhaust that well. Block that stuff off, and then just put the water to it and let the water run 10, 15 minutes, something like that, with the plugs out, and see if you get water into the cylinders. If you get water in your cylinders, you've eaten through. If you got water pouring out somewhere, it's eaten through. So that is one good way to test it. But then also something else is, after doing it, if you don't have your water in that, go run the engine for a little while. Run on the hose, run it at idle, go run it once on the lake, whatever. Be cautious of how long you run it, but then pull out your spark plugs and see what they look like. Do they have water on them, or do you have water in the cylinder? Is there a little bit of rust buildup? If there is, you got a leak. And at that point in time, even though you have cleaned the cooling system, you basically are rebuilding this engine. You have to tear it down to the block. You have to tear the block apart and find out where the pinholes are, weld it, sand it down. You are rebuilding the power head at this time, and you need to address whether or not it's really worth rebuilding that engine or not, because by the time you rebuild a block and rebuild an engine, you might have just been able to find a used one to buy, or bought a previously rebuilt one, because depending on how bad the damage is, you get in there and start welding stuff. Granted, depending on where the failure is, put it this way, like if it's on the cylinder or anywhere around the cylinder, that's dealing with compression of the engine. If it's on the cooling system, like let's say it's on the thermostat housing or the water jacket of the cooling system, your impeller at wide open throttle is generally brand new, only going to make 20 to 27 psi of pressure. Not a lot of pressure. You can sand the spot where it's leaking and fill it with JB Weld, and that JB Weld is going to hold it for the rest of the life of that engine, because again, we're talking about 20 psi at wide open throttle. If you're not even running wide open throttle all the time, you ain't got a brand new impeller. Some of them only make 17 psi. So, or 15. At idle, it's only making 1 to 2 psi. So you're not talking about high pressure. As long as you cleaned and prepared the spot properly, the JB Weld is going to hold that, and boom, that's a repair. Easy peasy. That's an easy fix. If we're talking about compression, totally different situation. A lot of times you can't use JB Weld to fix that. You actually have to weld it. But yep, unfortunate situation there, Rich. RSN Go, can you please make a video about how to repair anti-slip gel coat? That is a massive project. Depending on the anti-slip, if we're talking about sanded gel coat, which is just putting sanding non-skid on a gel coat, that's easy. You sand everything down, you roll your gel coat, you spray on your sand, or you could mix it with it and then roll it on. So that's easy peasy. You just sand and roll your gel coat. If you're talking about molded non-skid, which is where from the factory, when they make the cap, they have the pattern of the non-skid and it's molded into the gel coat. I personally cannot do that. Someone has to build the mold to make it. I'm sure it was going to take a long time, and only a professional is going to be able to do that. It's going to, that's a big deal, because think about molded gel coat. Molded non-skid is that textured pattern, and they pour gel coat into it, and that gel coat fills in all those holes, and that's your molded, that's the texture. So in order to take it out of the mold and now remake it and make a repair on that, you got to cut a section out, or depending on the pattern, have that textured mold to make it and patch it in there. That's a big deal. That's something you should leave to the professionals. Everybody knows at what point in time you got to call somebody to fix something. That's when you call somebody right there. Or you be prepared to spend the time and money to learn and do and perfect it. Jag Dio says, hi, can you run a Mercury 125 horsepower 1999 two-stroke without the thermostat? Technically, yes, you can. Do you want to for a long time? I would say no. The issue with so the thermostat regulates your temperature of the engine. So it uses cooling water to keep the engine running at a specific temperature, because you have all kinds of issues going on with running an engine in water. You're using raw water to cool an engine. Engine's creating heat. The water is cooling it. If you run in too cold of water and the engine runs too cold, you can create condensation. If you create condensation on a 4-stroke, you can accumulate water in the crankcase. So let's say you take your engine and you remove the thermostat out. It's a 4-stroke, and you run in 50-degree water. Let's make it easy. You run in 40-degree water, super cold water. The engine is probably super cold outside, and you're running this engine, and the engine's supposed to be getting up to, let's say, 143. That cold water flowing all the time through that engine, because there's no thermostat, it's just dumping that water. The engine's temperature is going to be probably 105, 110. I mean, it's going to be running stupid cold. When it runs that cold, the heat that is created from your cylinders firing and inside the crankcase is going to create the hot, you got, heat buildup, cold air, and moisture, because you're on the lake or on the ocean, and the moisture in the air is going to be very, very high. So the two differences in cold and hot creates condensation. That condensation is now going to be in your crankcase, and it's going to go down into your oil pan. You run that engine like that for, let's say, 50 hours. How much water is going to accumulate in your oil? Now all of a sudden you're running diluted water oil to lubricate your engine. It's going to cause a problem. On a 2-stroke, generally, you're putting oil into the engine, but virtually think about it the same way. You are putting that condensation into the engine, and the ports from the crankcase are going in to the cylinders. So that condensation is going to be fed to your engine. So now all of a sudden you're running, not a lot, but you're running water into your cylinders. You're going to be rusting plugs, you're going to be rusting rings, you're going to be rusting everything, because it's creating condensation. Will it hurt over the short period of time? No, it's not going to do anything. You could run probably quite a few hours without ever experiencing anything. If you run a long term on something like that, 125 horsepower, it's probably a 4-cylinder, 1999. If you run a few hundred hours on that, you'll probably shorten the life of that engine, and eventually a ring's going to fail, or you're going to have failures occur because it's not getting the proper lubrication and you're burning water. So would I do it in the long term? But again, that depends on where you're at, because if you're running in 90-degree water and the outside air temp is 90 degrees, you got heat and heat. So it's not, your engine's probably going to get up to temp. It's not going to create that condensation. So a lot of variables there, really. I mean, there's not really like a cut and dry answer, as there is with most boat stuff, because there's not, there's thousands of different engine models, thousands of different air temps, thousands of different elevation. Well, they're not thousands of different elevations, but I mean, I guess you could, from 0 to 8,000 feet above sea level. There's a bunch of elevations, water temperatures, like a bunch of stuff. So 1957 Cajun, what I don't get about this whole salt away thing is this. Salt away basically dissolves salt. Well, so does water. So tell me again what the point of using salt away is. Salt is corrosive. The issue here is not necessarily the dissolving of the salt, but what salt leaves behind. So the best way that I can describe this, again, I'm not a chemist and I do not really understand, the chemical breakdown of water, salt, minerals, all the other stuff. But I do know that salt, basically, as it dissolves and goes away, it has, in an electrical term, it has a positive and a negative ion. So whenever those positive and ion dissolves away, they react, and when they react, it creates the pitting. It eats metal. It creates basically a positive and a negative. You got a little, let's call it an explosion. It's not really an explosion. It's not really how corrosion works, but it does work in that fashion where you have a positive and a negative ion, and they react together, which eats into your metal. So every time you have salt on something and the water evaporates, the salt is left behind. It doesn't really dissolve it. It dissolves it to a point, but when it evaporates, the salt is left behind. And then that salt, the positive and the negative ions or molecules, whatever it is, the atoms, that is what starts to eat metal and pit stuff. Salt away, you spray salt away on there and it basically dissolves or neutralizes the positive and the negative. So now you just spray the salt away on there, and the salt away, you leave it on there. When it dries, it has neutralized that positive and that negative. So it neutralizes that effect that creates massive corrosion. So that's a very roundabout way to describe how salt away works, and why you would want to use it. So depending on where you're at would determine whether or not you want to use it. So especially up north. So, you wouldn't think about it. Well, I mean, I guess you would if you live up north. That when they salt the streets, you're running your cars through all that salt. So now all of a sudden, every winter, you're just throwing salt up on the bottom of your car. And then when you go put your car away, the water dissolves. Now you got all this, you got this salt sitting there. So some people, after the snow, they'll take salt away, spray off the bottom of the car, and boom, you've neutralized that effect. So it'll minimize the rust and the damage that it does. Gareth Barker, is it okay to use standard ATF in the trim motor? Yeah, you can. I think it's just Dextron 3 or something like that they want you to use, but virtually, I say virtually because again, there's thousands of different engine models out there, but virtually every one of the brands say if you don't have anything else like our brand of trim fluid, then ATF is fine. So yeah, for the most part, yeah. Let's just say Brian here says, one cool and practical feature I've seen on boats in Australia is the hand washing feature. A stainless steel button is flush mounted in the gunnel at knee height near the back of the boat. The idea is when hands are dirty, walk over and press the button with your knee and water comes out of a through-all fitting just below the rub rail for 5 seconds or so for a hands-free operation and without having to lean over the side of the boat to reach the water surface to rinse your hands. That's pretty slick. I do like that. I like that. I think that's why we added that one in here, because that is a pretty dope feature. I mean, depending on how you use your boat, if you're fishing a lot and stuff like that, and depending on where your washdown is and how you use that, I mean, that's pretty slick. Thank you, Brian, for that comment. That's it for this week. See you guys next week.